Bluyssen, for joining us. This is something that we've been trying to organize for a number of years. You were originally going to come here in 2020 to do, I think winter 2021, but that obviously didn't work out. So we are welcoming you virtually and really, really pleased that you can join us. I'll just go a little formal, but I'll just read Professor Bluysen's bio, just so you have a sense of her path and how she came to be with us today. So Professor Bluyssen received her Master's of Science at the Technical University of Eindhoven, and her doctoral work was done at the Technical University of Denmark. And she worked for more than 20 years as a researcher with TNO, where she coordinated several European projects on optimization of indoor environmental quality and energy use. And then she was appointed as a full professor in indoor environment at the Faculty of Architecture and the Built Environment at the Delft University of Technology in Delft. And there she initiated the Sense Lab, which is, we actually spoke about the Sense Lab in our class yesterday, which is a semi-lab environment, huge project sponsored by 25 companies. And I'm not sure if you're touching on that today, but really, really interesting facility.
Yes, you will see it.
And an extensive publication record, leadership in this area, and we're just so pleased to have you with us today. She's also the author of 2 books, the Indoor Environment Handbook, How to Make Buildings Healthy and Comfortable, which received the Choice Outstanding Academic Titles of 2010 Award, and her more recent book, The Healthy Indoor Environment, How to Assess Occupants' Wellbeing in Buildings, received the IDEC 2016 Book Award. So both of those books are available. If you're interested, maybe just send me a note. I think some people indicated in the survey, but we can coordinate that after the talk if you're interested, because they don't sell them in Canada, so we'd have to get them directly from Professor Bluyssen. All right, so what we'll do now, did you want to say anything, Professor Bluyssen, or shall I just begin the video?
Yeah, with remark to those 2 books you mentioned, you can order them via Amazon.com.
Oh,
so those are
wonderful.
not the books I referred to in the questionnaire.
Oh, sorry. Okay, that's great. Good
we can get back to that later.
Clarify that. Thank you. All right, so what we'll do, as I mentioned, just for those who joined a little bit later, we've pre-recorded Professor Bluysen's lecture. We'll stop at about 10 to the hour, so there'll be an opportunity to answer questions live. If you do have questions during the course of the interview, or the video, just pop them in the chat and then we can use those as a guide. So I will share my screen now. Hopefully this works. It did work at some point earlier. Okay. So can I just get a thumbs up? Are you seeing my screen? Yeah, wonderful. Okay, let's begin here. A couple different screens here. Here we are.
Before I start the lecture, The Need for Understanding the Indoor Environment and its Occupants, I would like to thank Dr. Mariana Tocci and Professor Russell Richmond for inviting me. I believe almost 2 years ago. But due to COVID, it was postponed and postponed until we finally decided to have it online, after all. Now, why is understanding of the indoor environment and its occupants so important? I probably do not really need to tell you, but just for the sake of it, I repeat what I tell our first-year students. People in the Western world in general spend 80 to 90% of their time indoors, that is at home, school, and at the office. Exposure indoors is therefore much longer than outdoors. The second reason why understanding of the indoor environment is so important, and we saw that also happening in this pandemic we are in, there are many diseases and disorders related to staying indoors. In the last decades, we are confronted with new diseases and disorders related to indoor environmental quality, such as mental illnesses, obesity, and illnesses that take longer to manifest, among which cardiovascular and chronic respiratory diseases and cancer. Think of asthma with children and COPD with adults. If you look at the scientific outcomes, it seems that staying indoors is not good for our health, even though the conditions seem comfortable enough, according to the standards we apply, according to the control strategies we have taken. This can partly be explained by the way our human bodies cope with the different stressors we are exposed to. We have several stress mechanisms available for that, and from research in different fields, it is clear that the relations between the stressors, those mechanisms that take place in the human body, causing the diseases and disorders, are very complex. I will tell you more about that later. Except for the health effects that we see today, the possible consequences for indoor environment of climate change is also a topic to be mentioned. The average outdoor air temperature is rising. Variation in weather condition is increasing. We experience more heat waves, more rainfalls, sudden wind speeds and storms. We observe an increase in smog frequency in urban areas caused by temperature rise, resulting in an even more polluted outdoor air. As a consequence, we will stay even more indoors due to the air quality, smog events, but also because of these sudden heavy rainfalls and wind speeds. Next to that, the air outdoors will be hotter and more humid. The outdoor air will need to be cleaned before it can be used to ventilate indoors. An airco might even be a must. Now, we certainly would like to prevent sites like these in downtown Hong Kong, where every apartment home, in many cases even every room, has an air conditioning on the outside of the facade. A third important issue is therefore the need for transition to less carbon emissions in the buildings and construction sector. The EU long-term energy strategy for 2050 is focused on creating a clean planet for all, which entails reduction of CO2 emissions and using less energy by all. To be able to realize that, in 2019, in the Netherlands, it was decided to retrofit buildings as such that no longer gas is used as the energy source, but all heating and cooling will have to be electric by 2050. What should be mentioned is that homes that already have been retrofitted to use less energy seem to not use less energy in real life. Behavior of people towards energy use and comfort seems to play an important role in this discrepancy. Moreover, more health problems seem to occur as a becoming result of these retrofits. So it is clear that the obvious challenge of today lies in the accomplishment of a sustainable and low energy built environment, and at the same time a healthy and comfortable built environment, and therefore a good indoor environmental quality. Now, what is indoor environmental quality? Indoor environmental quality is defined as comprising of indoor air quality, thermal quality, acoustical quality, and visual or lighting quality. Although aesthetic quality and spatial and ergonomical quality could also be considered as being part of IAQ, I do not include them in this definition. I consider only these 4 factors, and I will quickly go through them to show you what each of them comprises. Let's start with thermal quality. Thermal quality, the parameter we are the most familiar with, including aspects such as feeling warm, cold, draft, etc. In our daily conversations in the Netherlands, in any case, we often use these to describe the weather of yesterday, today, or even tomorrow. The big name most people know in this area is Professor Vanger, who tested his thermophysiological model in climate chambers in the 1970s, using several subjects, as you see here. His model has been and is still the basis for guidelines on thermal comfort. The hypothalamus in our brain takes care of the regulation of our bodily temperature. This bodily temperature is determined by the core temperature, the temperature of the central parts or vital organs of the human body, which is on average 37 degrees Celsius, and the skin temperature, which lies around 34 degrees Celsius. When we are cold, which is detected by cold receptors in our skin and through our blood temperature, the hypothalamus signals to our nervous system to close up our blood vessels and we start shivering in order to decrease heat loss and increase our temperature by moving. When we feel warm, on the other hand, our body will try to cool down by opening up our blood vessels and by sweating more. When people are dissatisfied with a certain thermal condition, they can suffer from thermal stress. Thermal stress occurs when one is not able to control its thermal balance, or when one believes or perceives it isn't possible. The psychological effect of expectations and the perceived individual level of control seems important. This is not taken into account in the model of Vanger. To deal with that, another model than the model of Vanger, based on field studies of people in daily life, slowly begins to win ground, the adaptive comfort model, in which the context and preference of the occupant are considered to be important. Both of these models, however, are focused on creating thermally neutral conditions. So in that context, it is perhaps interesting to mention that recently it was found that thermally neutral conditions do not have to be necessarily healthy. Studies indicate that increased exposure to thermally neutral conditions might be related to increased adiposity, an increase of fat tissue. This was first observed in experiments with rats and later with adult men. Actually, it means that when your body doesn't have to work to feel thermally comfortable, more fat is stored. Then lighting quality. Light plays a major role in architecture. The parameter visual or lighting quality comprises of aspects such as luminance ratios, and colors, but also aspects you would rather like to prevent, such as reflection here on the floor in a fitness center where I used to follow my aerobics lessons. But visual comfort is more than providing enough light to perform a task. Also, view is an important aspect to consider. And a very important issue with lighting quality is the use of natural versus artificial lighting, especially in relation to energy use. Then, also non-visual effects have been studied in relation to lighting, which I will tell you about in a few minutes. To be able to see, light enters the eye via the opening in the iris, the pupil. It continues through the lens and the jelly bodies before and after the lens, named the vitreous body, which absorb part of the light, while the rest of the light falls on the light-sensitive layer, the retina. A part of this retina, the fovea, is most sensitive to light, while the blind spot corresponds to the region where the optic nerve fibers leave the eye to transfer the information to the brain, where this is interpreted. In the retina, but mostly in the fovea, we can find the light-sensitive cells used for visual perception, the rods and the cones, of which the cones, we have three types, are sensitive to colors, while the rods give only achromatic or colorless vision. Now, not so long ago, a third type of light-sensitive cells was found. These cells are distributed between the rods and the cones in the so-called ganglion cells. They play a role in the control of the size of the pupil opening and the biological clock through influencing the production of the hormone melatonin by the pineal body, for which the hypothalamus is responsible. So, this third light-sensitive cells can also receive light, even though they are not used to see something. The so-called non-visual effects of light on our biological clock are partly their responsibility. Now, how do they influence our biological clock? Under the influence of light, the hypothalamus signals to the pineal body to produce melatonin, a hormone that makes us want to sleep. If exposed to light at night, the production of the antioxidant melatonin is immediately stopped. Alertness and core body temperature is increased and sleep is distorted. You can imagine that this might have consequences for people who work at night. Moreover, some years ago, the Dutch Health Council reported that studies have shown that people who are working night shifts are exposed to increased risk for cardiovascular disease and diabetes type 2. If we look more to the diseases and disorders specific for the eyes, several origins are possible. They can be, among others, caused by genetics in our genes as a result of aging, or caused by external factors. Color blindness, for example, is primarily a genetic originated disorder. It's the inability to perceive differences between some or all colors. The most common form of color blindness is the inability to discriminate reds, yellows, and green from each other. Complete color blindness, only seeing black, gray, and white, is not very common. With age, several of the eye's functions begin to deteriorate. The extent to which the pupil dilates, for example, decreases with age, and because of the smaller pupil size, older eyes receive much less light at the retina and therefore need extra light when performing a detailed task. Dry eyes, a common complaint of people indoors, is a medical condition in which the eye fails to produce tears or has an increased tear film evaporation. The most common cause of dry eyes is aging, but it can also be caused by thermal or chemical burns, or in epidemic cases by adenoviruses. What should be noted is that the dry eyes people often complain about indoors is rarely related to the relative humidity, but has been found to be related to pollutants in the air that cause irritation, draft, and also bad lighting. Then acoustical quality. Acoustical quality is influenced by noise from outside, such as traffic passing by, indoors, from quarreling neighbors, flushing a toilet, and by vibrations, for example, caused by the wind. Noise protection, noise insulation from noise outdoors and indoors are therefore very important issues, especially because we know how important a good night's sleep is for our health. Now, to be able to hear, a sound enters the external auditory channel, setting the eardrum and the ossicles in motion, which transmit these vibrations to the fluid of the inner ear, where nerve impulses are transmitted via the 8th cranial nerve to the brain, where it is interpreted. The inner ear also contains the equilibrium organ that acts independently of hearing, activated by acceleration in space and by the rotation of the body controlled. While the equilibrium sense is sensitive to low frequencies, vibrations, the auditory sense is more sensitive to higher frequencies, hearing. Sound has been associated with direct and indirect stress reactions. With exposure to high sound levels, we know that this can cause hearing loss, which is considered a direct effect. But also at relatively low environmental sound levels, it seems that noise can trigger the so-called anti-stress mechanism, an indirect effect in which annoyance is an important aspect. If we look into that anti-stress mechanism, we can see that in response to various stressors, such as noise, reflection, too warm, too cold, an increase of secretion of anti-stress hormones can occur. On the short term, adrenaline is produced and the body is prepared for action by producing noradrenaline. If the stressor is limited in time and perceived intensity, in due time the balance is restored. However, with prolonged stress, chronic stress, production of anti-stress hormones such as cortisol is increased, and a chronic imbalance in the hormones released during stress can occur. It has been proven, although simplified because there are other hormones and reactions involved, that cortisol plays an important role in the health effects of this chronic imbalance. High cortisol levels contribute to changes in carbohydrate and fat metabolism and can lead to anxiety, depression, and heart disease. While low cortisol production can lead to fatigue, allergies, asthma, and increased weight. These are in fact all the diseases and disorders I mentioned in the beginning of this lecture. Then direct effects of noise, of sound. Direct effects of exposure to noise depend on intensity and duration. A single exposure to an extremely intense sound, such as an explosion, may produce a severe and permanent loss of hearing. Repeated exposures to sounds in excess of 80 to 90 decibels may cause gradual deterioration of hearing by destroying the hair cells of the inner ear, and possibly subsequent degeneration of nerve fibers. Also, a gradual decline of hearing function usually starts after the age of 60. Then, motion sickness occurs when sensory information concerning body orientation and movement is inconsistent and can include breathing problems, yawning, a sensation of warmth, disorientation, nausea, and vomiting. Vertical oscillation of the body at low frequencies, for example when a building is vibrating from the wind, can be one of the causes. And then, last but not least, indoor air quality. Indoor air quality is determined by the pollution or pollutants occupants are exposed to over time. The pollutants that can be found in that indoor air comprise of gaseous pollutants, which some of them you can smell, for example molds in a bathroom, as shown here on the left, which can emit VOCs, volatile organic compounds, that are odorous and even irritating, and other pollutants that do not smell, but are important to consider. Think of carbon monoxide produced during cooking on a gas stove. And then there are several other components in that indoor air which influence the air quality, such as water and particles. These particles can be of biological nature, such as houtdamite and legionella, but particles can also originate from materials. An example is shown here in the right low corner of asbestos fibers, a well-known pollutant. Now, we perceive air with our nose, which contains the senses with which you can perceive air quality yourself. The nose comprises two nostrils with smelling organs. In each nostril, you can find one patch of yellowish tissue in the dome of the nasal cavity. This is named the olfactory epithelium. Two types of nerve fibers are embedded in that epithelium, which endings receive and detect volatile molecules, one for smell, the olfactory sense, and one for irritation, the trigeminal nerve. The endings of the trigeminal nerve are located all over the nasal respiratory lining, not only in the olfactory epithelium. Together, they form the common chemical sense. On being stimulated by pollutants, the olfactory nerve endings and the trigeminal nerve endings send signals to the brain, where the signals are integrated and interpreted. The result of this process is called perceived air quality. Now, while some people are not able to smell at all, they are called anosmic, others are able to detect certain compounds at parts per trillion, PPT level. Now, when you breathe in air to nose or mouth, the temperature and water vapor content of the air is adjusted and large particles are removed. Then the air moves on to the pharynx, the throat, the larynx, and enters the trachea, a long tube which branches into two bronchial tubes, or primary bronchi, that go to the lungs. In the lungs, the primary bronchi branch off into even smaller bronchial tubes, or bronchioles, which end in the alveoli, or air sacs. In those air sacs, the gas exchange with blood takes place. The oxygen of the inhaled air passes through the walls of the air sacs and blood vessels and enters the bloodstream. At the same time, carbon dioxide produced passes into the lungs and is exhaled. while larger particles are too heavy to stay suspended and will not be inhaled, of the sizes that can be inhaled and reach the lungs, the ultrafine or nanoparticles can, together with oxygen, pass the membrane of the lung cells, the alveoli, and in this way reach our organs via our blood. We have approximately 30 million alveoli in our lungs, with a total of about 85 square meter alveolar surface available for gas exchange with blood, and therefore also for these nanoparticles. Once in our lungs and organs, these nanoparticles can cause so-called oxidative stress. Oxidative stress occurs when there is an excess of free radicals, they steal electrons, over antioxidant defenses. Removal of electrons from cells through oxidation can create highly reactive oxygen species. Oxidative stress can damage cellular proteins, membranes and genes, and can lead to systemic inflammation. At a higher level of oxidative stress, cytotoxic effects may induce cell death. By the way, oxidative stress is also responsible for burning your skin by the sun, or when too loud noise ruptures the eardrum in your ears. Nevertheless, air pollution is probably the most important cause for oxidative stress indoors. But air pollution is responsible for more mechanisms. Air pollution can cause all sorts of health effects and can trigger several stress mechanisms. Fine dust can cause inflammation. Radon and asbestos fibers can cause lung cancer. Several VOCs can cause annoyance to toxic reactions. And several phthalates of certain plastics can cause a whole range of effects that are still hard to grasp. These are the so-called endocrine disruptors. And SARS-CoV-2 can cause COVID-19 by inhalation of air carrying very small fine droplets and aerosol particles that contain infectious virus, by deposition of virus carried in exhaled droplets and particles onto exposed mucous membranes, such as being coughed on, and by touching mucous membranes with hands soiled by exhaling respiratory fluids containing virus, or from touching inanimate surfaces contaminated with virus. Specific chronic respiratory diseases and disorders caused by air pollution are, for example, COPD, asthma, allergic rhinitis, and hay fever. While COPD is a chronic respiratory disorder that is usually progressive and associated with an inflammatory response of the lungs to noxious particles or gases, asthma is a permanent infection in the lungs. This means that there are always small infections present in the lungs that can cause several complaints. Asthma complaints can occur when people inhale certain compounds that trigger a response, such as several allergens, smoke, fumes, or pollution. Then allergic rhinitis is a name for an allergic reaction of the upper airways around the nose. This reaction can be caused by several allergens from both biological and chemical origin. Then hay fever is an allergic disorder. The immune system of our body overreacts to the presence of pollen coming from grass, trees, etc. Now, besides all those diseases and disorders, there are several building-related symptoms that have been related to exposure of air pollutants, such as symptoms of eyes and nose, the upper airway-related symptoms, tiredness, and headaches. In the past, if several occupants in a building were suffering from one or more of these symptoms, and no specific illness could be assigned, this was diagnosed as sick building syndrome. Now, how do we assess indoor environmental quality? The health and comfort indicators we are today familiar with can be divided in three groups of indicators to assess health and comfort of occupants. The indicators using the dose or environmental parameter, such as concentration of certain pollutants, temperature level, or ventilation rate. The ones focused on the occupant, such as sick leave, productivity, and number of symptoms or complaints. And indicators concerned with buildings and its components, such as certain measures or characteristics of a building and its components, or even labeling. Of these groups of indicators, the first one, dose or environmental related indicators, is used most frequently in guidelines and standards. But the mechanisms used behind these values or ranges are not always that clear. Take, for example, the minimum ventilation rate, based on either CO2, carbon dioxide, as an indicator for biofluence, or on certain emissions of building materials. Minimum ventilation rates have been discussed and are still being discussed for almost 200 years now. We have no clue what to take, even more now with the corona crisis. It is difficult to decide what to take. Current standards, such as maximum concentration of certain pollutants, ventilation rate and temperature ranges, are mainly based on single dose-response relationships. We assess indoor environmental quality, whether a building is healthy, on effect modeling. Now, this works well for health-threatening exposures for which a clear dose-response relationship has been determined. But complexity, number of indoor environmental parameters, and lack of knowledge make a total performance assessment using only threshold levels for single parameters difficult and sometimes even meaningless. So, according to the standards, a healthy building is a building that complies with the existing standards and guidelines for mainly the environmental dose-related indicators. However, from the previous lecture, it is clear that in order to assess whether a building is healthy, more is needed. A healthy building is a building that has the means to support the physical, psychological, and physiological health and comfort of its occupants over time. A healthy building has the means to influence health and comfort of its occupants through the thermal, lighting, acoustical, and indoor air quality of the indoor environment. A healthy building may also address drinking water quality and incentives for physical exercise and healthy eating, but those are beyond this lecture. So it's clear that next to the dose-related indicators, we need to also make use of the occupant-related indicators, preferable at individual level, because people differ and situations change over time. And we need to make use of building-related indicators and the interactions that occur in the environment over time. Interactions, such as, for example, chemical interactions between pollutants in the air and microbiological growth at indoor surfaces, but also interactions between different parameters such as light and thermal aspects when sunlight heats up the interior surfaces, thermal conditions and indoor air. Emission rates of most VOC increase with increasing temperature. Acoustics and indoor air via the introduction of ventilation air by mechanical ventilation systems, which can produce equipment as well as airflow noise, or via natural ventilation through open windows, bringing in the noise produced outdoors indoors. Indoor air quality, thermal environments, acoustics, and illumination are all interconnected in the indoor environment. But also at human level interactions take place. It is clear that the relations between the stressors, the mechanisms that take place in the human body, causing the diseases and disorders, are very complex. I guess I showed that in the previous part of this lecture. We are dealing with individuals in different scenarios, such as homes, offices and schools, and situations, for example, sitting behind a desk, in a meeting room, on the phone and sleeping. We are dealing with several stressors, physical, physiological, personal, psychological and social. and their integrated effects over time. And we are dealing with interactions between stressors in complex real-life exposure situations at the environmental level and interactions between various body responses to exposures at human level. It is clear that it is important to take account of the combined effects of stress factors in buildings on people, as well as their individual preferences and needs, and interactions occurring both at the environmental and human level over time. So not only the exposure to a certain stressor determines how one responds to that exposure, but also other factors, whether of psychological, physiological, personal, social, or environmental nature. This means that when a person is suffering from health effects, it is important to consider all possible stressors and factors, positive or negative, that might be responsible for that. It is clear that methods focused on the control of single environmental factors with the so-called dose or environmental indicators are not enough. We have two other categories of indicators that can be used. While the dose indicators provide concentrations of measured pollutants or indicators of air quality, such as CO2, in the occupant category, emphasis is being put on indicators that can give us information on the effects of stressors as well as possible stressors or risk factors for these effects. In the building category, certain measures or characteristics of a building are identified that could be considered as possible stressors or sources of stress. Now, several field studies have been performed in which an attempt was made to collect as many stressors and factors as possible, occupant-related indicators and building-related indicators, to determine patterns of stressors and preferences and needs profiles of occupants. You can see the list here, including also the journal papers in which they were published, those studies. The collection methods for these studies comprised of a checklist to collect the building-related stressors per scenario and a questionnaire among the occupants to collect information on all possible stressors, effects, preferences and needs of the occupants. For some studies, the checklist and the questionnaire was combined into one because we could not visit the homes or buildings. The questionnaire that you were asked to complete was similar to the questionnaire we used, including not only occupant-related indicators, but also building-related indicators. This questionnaire comprises of questions on personal factors such as age and gender, questions on your health and comfort, questions about your preferences for IEQ, questions about the building you live in, its surroundings, the occupants and their activities, possible water problems that occur or have occurred, questions about materials, furnishings and furniture that you have, and the possibilities for ventilation. Unfortunately, only 20 of you responded, which was not enough to perform analysis on. Now, to determine patterns of positive and negative stressors, multivariate analysis to find patterns was performed on the data collected. We did that so far for the 167 office buildings in Office Air, 2012, for 399 student homes in 2015, for 45 classrooms studied in the school study of 2017, and for 556 employees of outpatient areas in 6 Dutch hospitals in 2019. For each study, the collected building-related indicators were associated with the occupant-related indicators. To give an example, for the 399 student homes, the multivariate analysis showed that biological pollutants caused by pets, chemical pollutants caused by MDF from less than 1-year-old furniture in the bedroom, ventilation, opening windows in the bedroom more than once a week, and personal factors, like working out, were associated with having rhinitis in students. Now, this is clearly a good example of the multiple stressors related to having rhinitis, and thus the importance of considering all possible stressors when studying a certain disease or disorder. For determining profiles of occupants, two-step cluster analysis was performed for office workers in the Netherlands in the Officer project, for school children of primary schools, and for staff of outpatient areas and hospitals, all based on comfort, health, preferences, and needs. For example, in the school study performed in the spring of 2017, 6 clusters profiles of school children were determined based on their personal characteristics, health status, and preferences for IEQ. Among them, 4 clusters of children had specific concerns related to the IEQ factors. The sound concerned cluster, the smell and sound concerned cluster, the thermal and draft concerned cluster, and the light concerned cluster. However, the other 2 clusters of children did not show a specific concern. The all concerned cluster was concerned about all IEQ factors in the classroom, while the nothing concerned cluster did not show any concern. So in the field studies, we showed that both patterns of stressors and profiles of occupants can be determined from the information we gathered through questionnaires completed by the occupants and checklists used to collect information on building-related indicators. In the school study, additionally, interactions with the indoor environment were studied. Actions that teachers perform were asked to complete a questionnaire on the actions they perform to improve the IEQ in classrooms. Now, from the comparison between the complaints and the number of times that the teacher performed an action to improve the indoor environment, was concluded that those actions hardly had an effect on how the children felt. This could be related to the fact that not all children have the same needs, which makes it impossible for each teacher to satisfy each individual. But it could also be that a certain action improved the conditions for one child, while for another child the same action caused, in fact, a problem. Now, to unravel the model even further, in particular for schools and children, interactions at human level, affects, preference and needs were studied in the Sense Lab, with 335 children in 2018. Now, the Sense Lab comprises of the experience room, a room for integrated perception of IEQ, furnished as a classroom, as you can see here, and 4 test chambers, one for each of the 4 environmental factors: light, sound, air, and thermal aspects. While in these chambers tests on stressors and effects were performed, in the experience room, a workshop was held on preferences and needs. In combination with an exposure study to 36 different combinations of environmental conditions to assess the main, cross-modal and interaction effects on the evaluation of temperature, noise, light and smell by the children. The results showed that more acoustical panels had a positive effect on the children's assessment of sound, which is not surprising. But also a clear influence of fewer acoustical panels on children's evaluation of smell, draft and light was found. Moreover, sound type, especially children talking, affected the assessment of both sound and smell, indicated that children are perhaps preconditioned in their response by hearing children talk. Smell was in general assessed the worst, with sound type children talking, ventilation type mixing, and light type direct light, while no smile was in fact added. So, let's get to the conclusions. Research has shown that even though the conditions seem to comply with current standards for indoor environmental quality based on single-dose response relationships, staying indoors is not good for our health. There is clearly a need for understanding the indoor environment and its occupants. We need to acknowledge the fact that we are dealing with people who are different in their needs and preferences. And that the indoor environmental quality is more than the sum of its parts. This requires a new model, which takes account of the combined effects of positive and negative stressors in buildings on people patterns. Interactions at and between different levels, as well as the dynamic preferences and needs of occupants' profiles in different scenarios and situations. Eventually, this makes it possible to match profiles of people with patterns of positive and negative stressors for a certain situation. Well, thank you for listening. Now, then, because in the past 2 years, we all have spent a lot of time at home due to COVID, I would like to share with you a movie.
I might just pause it there. Just because we've only got a few moments left in the hour, and I can share this link later on in this video will be available. So I'd encourage you to watch the movie afterwards. It's excellent, very well done, lots of really interesting animations. But I'd just like to open things up now, just in the few minutes, if there are any questions for Professor Bluyssen about her presentation and this new way of thinking about the interaction between inhabitants of the building and their environment. Okay, maybe I'll kick one off if there are no hands. No?
Probably a lot to get. Huh?
Yeah, there's a lot to take in. No, there, Bowen, would you like to go? Would you like to ask your question?
Hi, Professor. Thank you for the presentation. It's very informative. I'm really interested in the interactions between different environmental factors. I've heard that, for example, like the color temperature of lighting may affect thermal sensation, and maybe air temperature can affect the perceived air quality. Is there any other factors that affects the perception of air quality? I think you mentioned that talking children can result in a perception of smile. Can you elaborate on that?
Yeah, it could be explained by the fact, and that's what we found in the field study we performed before the lab studies were done after the field studies. We found out that the children that we questioned complained about the smell in their classrooms a lot. And when we asked what type of smell, it was a farting of children. That's what they complained about the most, which was, yeah, I laughed also on that. Now, we found in the lab study that they were complaining about smell when the children were talking, when they heard talking children. We also found in the field study that their most annoyance with sound was talking children. So therefore, it seemed that when they hear talking children, they immediately think, oh, I will smell the farting now. This was the conclusion we made then. Now, some time after, we repeated these experiments in the lab with students of the age between 20 and 25, and they actually came up with the same. They thought that it was more smelly when they heard talking people in the room, which is something we need to investigate further, because it really seems that we respond with our brain to a lot of crowdness by also feeling that it's more smelly.
Thank you. That's very interesting to know. Could it be like the expired air, like the so-called bioeffluents, like the gases, the expiration?
No, because in the situation we asked these questions, we had exactly the same ventilation rate. We didn't add more children. We didn't add more materials. Nothing changed except for the fact that this noise was added by a stereo installation. So it was not that we added more children who were talking.
Oh, sorry, just to clarify. So it was just the audio in the room
Yes.
of not actual children talking. Oh, that's so interesting. So it is more the association with that sound. Sorry, I misunderstood that before. Yeah, that's really interesting. Thanks, Bowen, for the question. Any other questions? I know we're bumping right up against 3 o'clock or 3:01. I had one sort of final question. I'm sure if people have questions afterwards, I'm happy to field them, and then maybe we could have a bit of a follow-up, because there's a lot here to unpack and think about. And I was just wondering, because you've done a really nice job of sort of laying out where the physiological stressors are coming from each of these sources. And I'm just thinking about our whole capacity to deal with stressors, and if there are these associations, but when you're seeing these strange dissatisfaction with one IEQ parameter that seems to be linked to something else, is it as if we have this capacity for stress and it's combined? It might be just the acoustic discomfort that puts us over the edge, and that then leads into this dissatisfaction in all of these other areas.
This could be. That's why I showed you this anti-stress mechanism, which is simply based on creating hormones. And so your body responds by producing hormones, like the anti-stress hormones. That happens with noise, but it also happens when you feel too warm all the time. And so this is related to the mechanism. And that's why if you are stressed by several things, it could be that you go over this limit of number of hormones that are produced, or the level, which can create more than only dissatisfaction.
Yeah, even though under other less stressed conditions, you might be so totally satisfied with that particular environment.
Exactly. Yeah. What is also a good example is that you can unconsciously be stressed, for example, by noise during your sleep, even, or when you're just sitting in an office with an air conditioning system. There is this noise from the air conditioning system, but you are not consciously experiencing annoyance. What your body does, it keeps responding to this noise level that there is, even though it's very low.
Yeah, and I just wonder, there's sorry, I'm the one asking the questions. I need to wrap it up. I just wondered if you could briefly talk a little bit about how you see all of this work informing building design. I mean, there's a lot of interrelated factors, and it seems like people have so many different preferences. And this is something that I've really struggled with, thinking about how you actually talk to building designers about all of these challenges.
Well, that's why we tried to cluster people and to define profiles of people in certain situations, of groups of people in certain situations. We started with that, saying you cannot design a building for each individual. So it would be good if you could at least have some groups where you can design for. Now, it seems that is possible. For the schools, we had 6 profiles, but for the offices and the homes, we had 5 profiles. So that narrows it down already a bit. So you could try to have areas or certain sections in a building that are for a certain profile. That's how you could go ahead. Or that's another direction, that you could make things flexible. And so dynamic. It could well be that a person today fits in a profile number 1, but the next day he or she could be in profile number 6. That's it could also be, because it's very much context related, the way what you prefer.
Oh, definitely. And I think you could use that in the same way that we use design days, for example, in sizing a system. If we understand the range within these clusters, we can use that to inform our design. I see Professor Milgram has his hand up, so maybe we'll make this the last question. Would you like to jump in there? Nice to see you.
Sure. Thank you for your talk. Very quick question. Do you anticipate trying to introduce mask wearing into your model?
What?
Mask wearing.
I don't know what that is.
mask wearing.
Oh, mask wearing.
Mask. I don't think you mentioned that, but I can assume that would have a pretty...
because these studies were not in particular focused on measures for not getting ill by SARS or any other virus.
But I mean, as a matter of public policy going forward, I can imagine that whether there are mandates for children, for example, to wear masks in class, that's going to affect their subjective experience of the quality of the environment. It's sort of making a smaller environment that's part of the larger indoor environment. And
well, there is a video of about 9 minutes, which is still to be shown, which is connected to this talk, which shows the research that we have been doing the last 2 years. And so this lecture I just gave was from research we actually performed before, before the corona pandemic. And in there, we come with the different measures that you can use. And I certainly agree that we should go for a policy which gives us much more room for getting along with pandemics or with any kinds of disease. And we have never been focused on that so far.
Make it much more complex.
Much more complex,
Thank you.
Makes it even more complex,
Great. Thank you for the question. Just because I realize some people will have class right now, I think we'll wrap up, and I will just make sure that that link is circulated to everybody. And I would strongly encourage you to take a look at the 10-minute video at the end. It's just some really great work and lots of great options for different ventilation strategies in order to prevent infection within indoor spaces. So just a wonderful piece of work.
And also wearing masks and using cleaning devices. It's all mentioned.
It's all there. It's great. Thank you. Professor Bluyssen, thank you again so much for joining us so late in the evening. And as I say, I really hope we can welcome you to Toronto one day soon. And I'll, if we have any questions from the audience, I'll follow up with you later on. But it'd be great to maybe even organize a little subgroup chat with the people that are doing this for research. So thank you so much. A big round of applause from everybody.
Thank you too. Bye-bye.
Take care. Have a lovely weekend.
You too.
Bye.
Bye.